Yeah. Yeah, we have plenty of time, so you want to do that? Okay, okay. Uh, okay. Hello, everyone. I'm sorry. I've just discovered that I didn't have the right DisplayPort. So I'm changing PCs. This is the BESS working group session in Singapore. I still need to understand how to do full screen on that, and we're good to go. So Thomas couldn't make it. The usual note well. Blue sheet. Right? Yeah, but I didn't find this full screen. Whoa, we're nearly there. Okay. Oh yeah, excellent control L. Woo! Woo! Thank you, Greg. So blue sheets. Agenda. We have a bit of time today, so I'll let discussions flow. We've given all the time people requested, and we have kind of long presentations, so don't hesitate to participate. Minute taker. I'm alone. Anyone willing to help me? Thank you. Yeah, quick status. We had a pretty calm intermeeting period with only 2 working groups sent, 2 documents sent to ISG. Now Alvaro has 5. 2 adoption, the DC gateway and the NR flags. Just a small heads up on the NR flags. We'll be moving quite rapidly from the adoption to working group last call, because it depends of another document, proxy, ARP-ND depends on it, and it's ready for working group last call. So we want to advance these 2 documents together. We have a bunch of documents in our hands. Ali is there or not? No, that's too bad. And few documents ready for working group last call. We'll be starting these after the meeting, and we don't have any document. Ali.
Yes.
Last meeting, so 3 months ago, you said soon for resolving the pending issues of EVPN inter-subnet forwarding.
Is it with respect to which draft?
Yeah, EVPN inter-subnet forwarding.
All right. I've edited. Eric has had a long list of comments, so I'm 2/3 through it. And
no, I'm not talking about E3. Eric.
Eric Rosen.
Okay.
Right.
Okay.
So that I'll take care of it in January, unless we are in hurry. Then I'll try to expedite it to next few weeks.
Okay, but it's still on your to-do list. Okay, I'm fine. I just don't want that it dies.
No, that definitely is. And then I got a couple of comments with respect to the drafts that are in the ISG queue. So whenever we get to that,
okay,
I'll express my comments.
Perfect. So when I was saying, we don't have any document to our knowledge which is ready for adoption. If you think you have a document which is ready, let us know. Just a heads up on our relation with NVO3, which is expected to be closer in coming. Ali.
Can you please go back to the previous slide? With respect to the ping, we got ping and BFD draft, and the ping LSP, EVPN LSP ping, that is in pretty good shape. And we would like to request a working group call on that. And we've had several iterations of it, and The last review we had, there were a couple of, minor tweaks that needed to be done, which we did that. But it is in pretty decent shape right now.
Can you send me an email?
Absolutely, sure.
Thank you. So yeah, I was saying we'll be working closely with NVO3 from now on as work in NVO3 on Geneve develops, and they'll be working on applicability statements, and we will likely be working on control plane extensions for that. So watch out for documents in both groups and be ready to review them as they go through their important phases, like adoption and last call, but also anytime. Adrian wants to speak on L2SM, so I'm giving him the mic.
Thanks, Martin. I'm Adrian Farrell, co-chair of L2SM working group. We produce a Yang model for representing a layer 2 VPN service between an operator and the operator's customer. So not down in the bits and bytes, but a description of the service. Our Yang model is reaching completion, and we would particularly like people to review it, obviously especially operators, because they are the consumers, but it's also valuable to have input from people who understand the delivery of L2 VPN services. So just to remind you again that this is not how you build the service, this is how you describe the service between an operator and a customer. Please come and review the document, which you can find in the data tracker and on the charter page. Thank you.
Thank you, Adrian.
Good morning, everyone. I'm Liu Yisong from Huawei. I represent the multicast Yang design team to give the presentation of the MVP Yang model. Last meeting in Chicago, we have introduced the whole MVP Yang model. This time, I'll introduce the updating information. Now, from the last meeting, we have updated according to the NMDA and some review comments from the Yang design team, and we have passed the validations. For the Yang model's architecture, we have updated to the NMDA version. We still have the two hierarchy. The first is the instance level, and the second is the tunnel level. We have give some detail of the updating information. The first one is that we add a signaling mode of the MLDP embedding signal reference to the RFC 7246. So now we have the three type of the signaling mode. The second one is that the ASM mode in the private network. We change from the boot type to the enumeration type. The third one is that we add the element of the switch word wildcard mode. Reference to the RFC 66 and 25. That we have four type of the wildcard mode. So welcome to the more comments and more vendors and carriers involved. And this meeting, we will request the working group adoption.
Time for comments? Good. Hi, my name is Sue Hares. Hat on at this moment is IDR co-chair. Question, have you harmonized this with the BGP model? There was a prototype I cannot say that, for network management data stores architecture, NMDA model. Have you looked at that yet? If not, if you take a look at it, I'll send you email about it.
Okay.
Not looked at it yet, right? Okay. Second, have you looked at the base BGP model? What
No,
relationship is it to the base BGP model?
Oh no, I haven't. We designed a model follow the network instance model.
Okay. Well, why don't we take that offline? I'll send you some email. There's a base BGP model. You may have 3 answers. Doesn't not align, not connected, not aligned, or we'll work on it and we'll figure out which one of those answers. I'm sure it's one. Second question, this is more to the chair. IDR just finished a working group last call on its tunnel attributes. How does this relate to this, to the tunnels here? And do I need to worry about the harmonization of getting a tunnel Yang model coming up?
So since this is still an individual draft.
Yeah, if you, excuse me, would you go back 3 slides? 1, keep going. 2, keep going. 1 more. Okay. In here, there was a tunnel, MPV, SPD tunnels. There's a tunnel attribute out of IDR. Do we need to have these Yang models interacted? If you think so, then I'll dig into it along with this. It's IDR's fault because we're late in getting the base stuff out, but we don't have an augmentation to our base for our tunnel attributes.
Let me think this through.
Okay.
And get back to you. But
That's fine.
Yeah,
Both of you, this was just a question to figure out if we need more work. Really excited about this work. This is really good work. Thank you for doing it.
Thank you.
Stefan Likowski from Orange. Are you augmenting the layer 3 VPN model? Or is it something that is completely apart?
Sorry, can you repeat?
Oh, sure. Sorry. Are you augmenting the layer 3 VPN model? Or are you building a completely new hierarchy?
I just augmented firstly, I augmented from the layer 3 VPN model. But now I think because I think that is too tight to the L3 VPN Yang model.
Yeah, but
I update from
an operational point of view, this is a layer 3 VPN. You just add multicast capability in it. But you're tied to layer 3 VPN.
Okay.
From my operator point of view, I more see this as an augmentation of a layer 3 VPN. But that's just my opinion.
Okay.
Thank you. I think we start the discussion on the list.
So I have next 40 minutes. Try to keep everybody awake. The first presentation is MVPN and MSDP source active route interoperation. Let's first take a look how the MSDP works. Very quick review. In this picture, I have 6 RPs used for PIM ASM. We have a first hop router on the upper right corner. It sends PIM register messages towards RP1. So RP1 now learns the source. It will send MSDP source active messages to other RPs. Eventually, it arrives at RP6. And there is a last hop router that's connected to the receivers. It sends a start G join, PIM start G join towards RP6, and it stops there. And now RP6 has a start G join, and it also has SA messages. So now it has the source information as a group information. Now RP6 will send the PIM SG join towards the first hop router. So this is how PIM ASM works with the MSDP and multiple RPs. Notice that in this picture, we have continuous PIM MSDP sessions among those RPs. MVPN has a similar situation. Here we have 4 PEs connected connected by this provider network. At the top, we have the customer RP in a particular VPN, and it discovers the sources information from the first hop router. And between PE1 and CRP, the customer RP, there is MSDP session. So PE1 learns the source from by the MSDP message, and therefore it will send MVPN source active routes to other PEs. Now in this picture, notice that at the bottom we have a CE that is not a customer RP. So when it gets the star G join, you will continue to propagate the PIM join towards PE3, which is on the path towards the RP. I didn't the customer RP at the top. So now the MVPN SA routes from PE1 is received by every PE, and in this case, PE3 has a star G state and it has the source information. Then you will send MVPN SGC multicast routes to PE2. So this is MVPN. One particular mode of MVPN works with the SA routes and the star G, SG joins. Notice that the PEs here are just like the RPs in the previous slide. And the MVPN SA and the MSDP SA are quite similar, except there is one caveat. So in this picture, notice that the CE is actually another customer RP. Therefore, the star G join from the last hop router will stop there. It does not go to PE3 anymore. On the other hand, while a PE advertises MVPN SA routes from received MSDP messaging, it does not do the other direction. So PE3, when PE3 receives the MVPN SA routes, it does not send the MSDP SA to CRP2. Now we have a disconnect. So the PE3 has the source information, but it does not have the star G state group information. The CRP2 has the star G information, but it does not have the source information. Now it's disconnected. So to fix this problem, we have to have MSDP session either between PE1 and PE3, or between PE1 and CRP2, or between CRP1 and PE3, so that we can have continuous MSDP session. This is just oversight or in the original MVPN specification. It didn't consider this situation. Now, those additional MSDP sessions are not desired for two reasons. One is that those sessions are per VPNs. The different VPNs will need different VPN session, those MSDP sessions. And additionally, those additional MSDP sessions will cause excessive MVPN routes. In this example, PE1 learns the sources from CRP1, it will advertise MVPN routes. And PE3 learns the same source either from PE1 or from CRP1 over the MSDP session, will do the same. So now we have too many MVPN routes. So the solution is quite simple. It's just something that we didn't consider in the original MVPN. Now, for when you have when P receive MVPN essays, and if it also has MSDP session to another peer, then you will just trigger MSDP essays from those MVPN essays. In the MSDP essay, there is a RP information carried, but MVPN's essay route does not have that information. So we propose to have the MVPN essay route to carry an additional extended community to specify the RP address. I presented this in the MBOND session as well. I got a good comment back that in this situation, we're using MSDPs between those RPs. But another mode to work with multiple RPs is that you do not use MSDP, but you just forward PIM register messages among those RPs. So that mode is very similar here, and the solution should also cover that. So basically, when PE3 gets the MVPN essay route from PE1, it should send a PIM SG register towards CRP2 in this picture. So that we're going to update this spec to handle that as well. There is ongoing discussion in the MBOND about deprecating interdomain ASM, but that is not deprecating MSDP itself. And more importantly, the situation I'm talking about here is for intradomain, because MSDP is also widely used by many customers for their intradomain, and so that this procedure is still applicable. So we are seeking the working group comments. I've already got some from the MBOND session. The solution here is quite simple. The scenario, problem scenario is real. We got run into this situation quite often. So I'm actually seeking working group adoption now, so that we can move forward. So this is my first presentation.
Who has read the document? Okay, a bit less than 10 hands. Thank you.
Next. Controller-based BGP multicast signaling. This is a new draft based on earlier drafts that I presented before. We have co-authors from several companies. So first, I'm going to give a very quick review on the base drafts, BGP signal multicast, and then move on to this new draft of controller-based BGP multicast signaling. So to some operators, multicast is complicated and they don't like it. And to some operators, it's necessary for their network. So they still need a solution. And and BGP signal multicast can be a solution, can provide some mitigation to their, whether it's to their discomfort or to the complexity they have to face with the multicast that they have to deploy. So essentially, it's just to use BGP to signal multicast trees or to signal MLDP tunnels. It's just a replacement. With that, with the BGP signaling, we can remove PIM soft state and we can remove PIM ASM complexities. And we can consolidate the BGP signaling. And apparently, with SR network, some operators are quite eager to remove the additional protocols from their network. And the BGP, it will be a good choice for them. I'm going to skip this slide. It's covered in the drafts. It's basically you just use the PIM messages to replace use BGP messages to replace PIM messages or replace MLDP label mapping. And the reason for that it addresses PIM ASM complexity is that we use the BGP methods that to discover sources, and then the last hop routers will just establish source-specific trees towards the sources directly instead of going through the a shared tree. And because it replaces a PIM or MLDP to set up the trees or tunnels, the transition from the existing PIM signaling or MLDP signaling can be incremental. So this is an example of how the BGP signal multicast can work. Each router independent. Okay, so is this the PDF or?
It is the PDF.
Okay, all right. So
you had animations?
Yeah,
Sorry,
but that's okay. I'll just try to explain. So here I have 5 routers. R0 is the root of the tree. We have 2 routers at the bottom, 3 and 4 are the last hop routers. So R3 needs to join the tree, so it sends a BGP message towards the R1. That message can be either through the over a direct BGP session, or it could go through RR. In this picture, it goes through RR. So R3 sends a message, a BGP message to the RR reflected to R1. And then R1 does the same, sends a message to RR and then towards R0, so on and so forth. The tree is established like this. Now, so in this mode, you notice that RR in the middle, it's reflecting the routes back to the routers. Now, if you think that what if you replace that RR with a controller? The controller that knows everything, that knows the topology, it knows the rules, and knows the leaves, and it can use whatever algorithm, whatever input, whatever constraints to calculate that tree. So once the controller figures out that tree, it can just directly go to each router, ask each router to set up the forwarding state that way. And you can do that using the same messages that we propose to use for the hop-by-hop receiver-initiated trees. With that, the routers become very simple. They don't need to do all those RPF thing to figure out where my upstream is. Now the routers just become this is like a static routes, except that the static routes are coming from the controllers.
I have a question from operational perspective. For the last 15 years, we've been building BGP-free cores. Do you expect people to deploy BGP on every peer router in the network to get the state populated?
Right. So in the old days, BGP-free core often used for the unicast. And nowadays, BGP is becoming more and more popular in some networks. Some customers they like to run BGP on every step, and also on the other hand, even we use BGP here hop by hop on every router. Those BGP sessions and they do not have to be used for unicast. They could be only used for multicast.
I understand they're very lightweight. At the point you still need to run BGP, you're affected by BGP bugs and it change operational model significantly.
I'm sorry, I cannot hear you well.
Even so, the BGP session is very lightweight and not used for unicast. You still have to run BGP on every router. So BGP bugs will affect you. It changes the operational model significantly.
You're
Something
right
to
that
think about.
you have to run BGP there. So if you are a customer who does not want to run BGP everywhere, then this is not a solution for them. I agree. Yeah. Yes. Yeah. So now there are two differences from the hop by hop signal case. First one is that in the hop by hop case, notice that R0 has two downstreams. So you would need to R0 will need to receive two BGP messages, one from each downstream to set up the state. With the controller only need to send one BGP messages to the upstream and specify all the downstream in the tunnel attributes. So here we propose to use a new composite tunnel that basically lists all the component tunnels that you want to send traffic out of. Another difference is that the label allocation. Now this gives us more options for allocating labels in the label tree case. It could be that the label could be allocated from the controller's own label space, or it could be allocated from the common sRGB, or it's just like allocated from each router's local label block that the controller somehow has learned. In the first two cases, we can actually do per tree label in the unidirectional tree, or we can do per tree direction label in the bidirectional tree case. This could simplify the router's operation because just like in the unicast case in SR network, you can use the same label on all the routers for a particular tunnel. That would make monitoring and troubleshooting easier. However, if you want to do that, then you will need to do neighbor-based RPF in the data plane, because when the topology changes, the forwarding state may not be updated in a synchronous order, in the exact order, so that if you don't do RPF, then you may get into traffic loops. So if you use per tree label or per tree direction label, then you need to use an additional label in the stack to identify the neighbor, and you do the RPF checking on that. And if you also, if you allocate the label from the controller's own local base label space, you need another label to identify the controller. So that's basically a context label for the upstream allocate labels case. You can use multiple controllers in your network. They can calculate tree, they can do the signaling independently, as long as all the routers on a tree or on a tunnel choose the routes from the same controller, it's going to be fine. And in the labeled case, even if somehow the different routers on trees choose the best route from different controllers, the traffic forwarding will not work out, but we will not cause a traffic loop. I already mentioned that if you use per tree label, then in the bidirectional case, you need to use a different label for different direction, upstream direction or downstream direction. So in summary, with BGP signal multicast, if we still use the hop-by-hop receiver initiated tree, that can just replace PIM or MLDB signaling. That can remove PIM refreshes and remove the PIM ASM complexity. And going one step further, if you use controller-based signaling, it's well suited for SR networks, and you can delegate a tree calculation to those omniscient, omnipotent controllers that knows everything. You figure out the tree, and then the routers just become dumb routers that set up falling state according to the message from the controller. So right now, those two drafts, we still need to polish them. Once we do make it in better shape, and then we can try to progress the work here.
I got a couple of questions. In the first slide, you mentioned that some of the concern of the operators, and that is a per tree estate, complexity of ASM and PIM soft state. In this proposal, you're trying to address 2 out of 3, right? Still, we're going to have per tree estate in the core.
Oh yes, there is still a tree in the core.
Okay.
Yes.
Then this is a proposal for both IP transport as well as MPLS transport, right?
Yes.
With respect to the IP transport, I can see, some benefit for it, but with respect to the MPLS that is trying to replace MLDP, I fail to see the benefit. I mean, except what you mentioned that, reduction in number of protocols, but that is pretty subjective, given that MLDP to use for the tree setup is also not that complex.
I agree, but there are customer operators who really want to just
Right. I can see some network, like a MSD, MSDC kind of scenario that they want to just use BGP. I can see some certain scenario that can be applicable, but sort of they're in the niches. And this is it accurate to say that this is an interim solution till beer comes along?
interim solution before.
Till beer comes along.
Correct. If your network can do beer, that will be the ideal solution.
Okay. I would appreciate if you clarify some of these points that, with respect to the specific network that this is targeted for.
I think I have some points in the draft, but I will check and make sure that they are in both phases. Yes.
Okay, cool.
So this is an update on inter-subnet multicast for EVPN. This is the first revision of the drafts. We have Eric Rosen joined as the editor. He basically revamped the drafts with a lot of details and explanatory materials, and also we have enhanced the MVP integration section, and we have the additional details for interworking with legacy PEs. For this presentation, I'm going to focus on 2 things. One is the characteristics of this solution, optimized inter-subnet multicast, and also the MVP integration. First, review the key concepts of this optimized inter-subnet multicast. What it is about, So let's say you have a EVPN network with multiple, and for particular tenants, you have multiple BDs, and you have you have IP multicast that needs to be delivered to receivers in different BDs. How can it be done optimally? If you don't do anything special, things will still work out, but there will be some inefficiencies, which I will not talk about in this presentation. But to optimize it, we have defined these procedures how to do it. So if you receive a Ethernet frame from a local attachment circuit in a BD, you just do a layer 2 switch to local receivers in the source BD itself, and also switch to remote PEs using layer 2 tunnel. That switching is either in the source BD itself, if a particular remote PE is also connected to this source BD, or it could be in a different BD, we call it the supplemental BD, which is present on all the PEs of a particular tenant. And then additionally, it's going to route it via IRB interfaces to local receivers on other BDs. Here, notice that we are emphasizing the local receivers. When you route the packets down an IRB interface, typically the packet is going to be sent out of local attachment circuits and to remote receivers in that BD. But here, we're going to intercept that sending to the remote receivers. And on a remote PE, when you get the frame from a layer 2 tunnel, again, you switch it to local receivers in the receiving BD. Remember that receiving BD could be the source BD itself, or it could be the SBD. Additionally, it will route it to IRB interfaces to local receivers on other BDs. And for packets from an external source outside the EVPN, you just route it by IRB interface to local receivers, and also route it down IRB interface to the supplementary BD. That will cause layer 2 tunneling to egress PEs. Now, there's a difference between the third bullet and the earlier 2 bullets. If the package that is routed down SBD IRB interface is going to be sent across the core to remote PEs.
Hi, Ashutosh from Avi Networks. In first case, when the frame is coming from local attachment circuit, how do you decide whether to tunnel it in source BD or supplemental BD? Hi, Ashutosh from Avi Networks. In first case, where you have frame coming from local attachment circuit, how do you decide whether you need to send it to in source BD or supplemental BD in terms of layer 2 tunnel?
We have procedures defined in the spec. In short, basically, you go through the IMAD route or SMAD route you received in the SBD itself, because SBD is connected to every PE, so you would know which PE to send traffic to. And then you also check if that remote PE that you need to send traffic to also advertised IMAD routes for the source PE BD. So if you see the IMAD route from a remote PE for the source BD, you know that that remote PE is in the source BD, so you just send it using the source BD itself. Otherwise, you send it to that remote PE using the SBD.
Okay, so in case of P2MP tunnels, you would choose either, or would you make 2 copies?
Yeah, in P2MP, we also have procedure to handle that, but I think we don't have time to go through that in this presentation. But
my
can
question
talk
was
about
whether it was
offline.
1 copy or 2 copies. Basically, that's
1 copy.
okay.
1 copy. So There are several characteristics we want to emphasize here. The first and most importantly, it maintains correct Ethernet emulation. For receivers on the source bit itself, you see an unaltered frame. Same source MAC address, same TTL. Whether the receiver is attached to the local PE, the ingress PE, or attached to a egress PE. But when for receivers attached to other BDs that is different from the source BD, you will see that the TTL is decremented by 1, and the source MAC address changed the router's source router's MAC address. Again, this does not matter whether it's attached to a local PE or remote PE. And if you don't have sources or receivers for particular group that is external to this EVPN, then you do not need to use PIM, you do not need to use the RP or PIM register, all those complications that PIM ASM brings. So it could be that you don't need to run PIM at all, unless you have the external sources or receivers. The second one is that it works with all tunnel types that MVP, the EVMP supports, and whether it's MPLS or VXLAN. The routing or replication throughout this tenant domain itself is optimal. There is no change to EVP multi-home procedures. The split horizon label-based procedure for MVPN infrastructure, or the local biased procedure for VXLAN infrastructure still just work the same way. It builds on top of already deployed features, S-band routes, and IRB interfaces. It maintains clear distinction between layer 2 and layer 3 multicasts. The draft also covers how to interwork with the legacy PEs that does not support OSN or may not even have support IRBs or S-band routes. But I'm going to skip those 2 slides about interworking with legacy PEs. Interworking with external multicast infrastructure, whether it's PIM or MVPN, it's basically covered by the same model, same architecture. We handle the EVPN receivers with external sources, or external receivers with EVPN sources. Basically, some of the EVPNs become a gateway to the 2 worlds, between the EVPN world or the external world. We call it MAGs. EVPN basically appears as a stop lane to the external network, and those the gateways are basically as first hop routers to the external network for the sources in the EVPN, or it becomes the last hop routers for receivers in the EVPN. In the MVPN case, the MAGs run both MVPN and EVPN procedures. And they move traffic between MVPN and EVPN. And if you are a vanilla MVPN PE or a vanilla EVPN PE, they do not see each other. They do not, MVPN PEs do not see EVPN PEs, and EVPN and vice versa. We designed this trying to follow a principle that no entanglements. The MVPN domain and EVPN domain operate independently, so that we can have a clean, clear interface between the 2 domains. Each domain has its own native control plane and data plane. The interaction between those 2 planes are achieved through the layer 3 multicast states that each control plane recognizes. Procedures internal to MVPN or internal to EVPN do not require modification to accommodate other domains. For example, EVMP multi-homing procedures do not need to be altered. And intra-subnet multicast is still switched. So you can see the Ethernet emulation is still maintained. Now, the subsequent slides talk about how the interworking between MVP and EVP is achieved. Basically, operators choose which PEs become the gateways, the MACs. The choice will depend on the deployment scenarios. You could make every EVPN a MAC, or you could just put a few MACs at a natural entry or exit points to a DC, or anything between, just purely based on your requirements. If you need optimal routing and replication between those two domains, obviously we want to put the MACs along the best path between those domains. So there are situations where you may need to put every EVP PEs as MACs, but we try to avoid that as much as possible. So the reason is that adding the MVP procedures to those EVP PEs brings added complexities in configuration, the procedures, and provisionings. Obviously, as an operator, you will have to evaluate the trade-offs and do the best for that particular deployment scenario. So for MVPN, the PEs need to advertise unicast routes that is used for multicast RPF purpose with additional information. Here, the MACs will do that. They will export VPN IP routes for the multicast sources in the EVPN into MVPN domain. They do not have to be host routes. They can be subnet routes, depending on your deployment scenarios. On that other directions, they will import MVPN, the VPN IP routes from the MVPN site into EVPN site, whether as type 2 or type 5 routes. So if you have a EVPN receiver and MVPN sources, if that receiver is attached to a MAC, then the MAC will just use ordinary MVPN procedure to pull traffic from the MVPN ingress PE and deliver traffic to local receivers. But if a EVPN receiver is not attached to the MAC, it's attached to a different EVPN PE, that PE that is attached to the receiver will use EVPN procedures, use EVPN SMAC routes to try to pull traffic from one of the MACs. And then the MAC will in turn use MVPN procedure to pull traffic from the ingress PE, MVPN ingress PE. And if you have MVPN receivers with EVPN sources, the MVPN egress PE will use MVPN procedures to pull traffic from an MVPN PE that advertise the best route to that source. Now that MVPN PE will be a MAC because it's that MAC that advertised the route to the source. Now, if the source is not attached to the MAC, then the MAC that has received MVPN requests from the egress PE will further use this OISM procedures to pull traffic from the real ingress EVPN PE. Now, there is a trickier situation. I have a picture for it here. In this picture example, I have P1 through P3, P0 through P3. P0, 1, and 2 are on the EVPN side, and P1, 2, 3 are on the MVPN side. We have a source attached to multi-home to both PE1 and PE2 on the EVPN side. And as the source being a multi-home source, it uses its hash algorithms to choose which link to send traffic. So for a particular flow, it can send to PE1 or to PE2. Nobody knows deterministically. Let's just say that it sends traffic to PE1, and we have a receiver R attached to MVPN PE3. Now, the MVPN procedure requires PE3 to determine which PE is the ingress PE. In this case, both PE2 and PE1 could be a potential ingress PE for MVPN because both advertise the same unicast route to the source. But there is no way for PE3 to figure out which one is the correct ingress PE. And it could also be that at one moment, PE1 is the ingress PE, and PE3 luckily picked it correctly, but next moment, the source may decide to switch to send traffic to PE2. And what does PE3 do? So here, let's just say that PE3 picked the PE2 as the MVPN ingress PE, but the source is sending to PE1. What happens? Using the EVPN procedure, the PE1 will deliver traffic to PE2 using EVPN, and PE2 will further send the traffic down to PE3. When we look at this situation before, for a moment we thought that, okay, the PE1 could just send the source active routes when it received the traffic from the source, and then PE3 would choose a PE1 based on the source active routes. But it turns out that is not applicable, viable, because in MVPN procedures, we do not use SA routes to influence our ingress PE selection. But because we have separate EVPN and MVPN procedures here, the P1 will send traffic to PE2 on the EVPN side. Therefore, no matter what PE3 choose on the MVPN side, things will still work out. So this is the first revision. We can still have some work to do with the draft. We need to ensure that we alignment with the new PIN proxy draft, and we need to ensure the alignment with EVPN IPN unicast interoperability draft. However, we believe that it's got to a state where we think it's quite mature, that we would like to request our working group adoption, and we can work on the remaining issues collectively in the working group.
Jorge Rabadan, Nokia. Speaking as a co-author of this draft, so this revision, I think it's pretty good. It's pretty mature, and especially Eric and Jeffrey have done a great job. So I agree with Jeffrey. I think it's at this point in time, it's ready for working group adoption. And I also wanted to reinforce the two messages. So first, this is a very natural evolution of the current EVPN solutions for unicast. And secondly, I believe it will make the deployment of layer 3 multicast in a very simple way in EVPN networks.
Alice, Jesse, I'm also a co-author of this draft, and this rev definitely is a great improvement over the previous revs. So we went from 20 pages in the previous rev to 60 pages in here, and I think it would help if, because of the complete revamp of the draft, give some time to make sure that everybody get a chance to read the latest rev. And then have the working group call.
Who in the room has read the document? Out of these, who thinks it's ready?
Same number, maybe -1. Okay. Thank you, Jeffrey. Excellent timing. Look like it. It's gonna be tricky because it's here. If you give me a couple of minutes, give me a few seconds. But Jeffrey will be jealous.
Yeah, sorry about the PDF is messing up with the fonts. So we are trying to pull up the PowerPoint version. So in the meantime, my name is Jorge Rabadan, Nokia, and I'm presenting this draft EVPN and IPVPN interoperability or interworking. This is a revision 00, but there is a long history behind this draft and a lot of work. Basically the history is that we had in the past we had a draft that was addressing the EVPN and IPVPN interoperability, and we also had another draft that was talking about the BGP path attributes propagation between EVPN and IPVPN. So the authors of both drafts basically we sit down and we said, okay, doesn't make sense to have two drafts to address pretty much the same solution. So let's start from scratch. Let's merge both drafts and let's address all the concepts in a single draft. So we've been meeting for a few times in the past months, and this is the result of it. So even though it's a revision 00, there is a lot of discussions behind. And yep, that's the one. Okay. Thank you, Martin. Yeah, okay. I'm afraid of the rest of the slides also being broken.
Give me 1 second. I'm putting it. You need the two?
Huh?
You need the two. Do you need the two presentations in PowerPoint?
If possible, but especially this one. The other one is less important because it's just a couple of slides.
No, it's up.
Say that again, sorry. I don't get Ali's jokes. All right, thank you, Martin.
You're welcome.
Yeah, so this is the list of authors for this draft, and this is the first time that we present the result of the merging of the two drafts I was talking about before. What is the problem we try to solve? So we see more and more EVPN being deployed for layer 3. So we all know that is a great evolution for VPLS and layer 2 services, but now we see it more and more for layer 3, and not only in the data center environment, but even in other places too. So what that means is it's at some point you will have tenants that have CEs that are connected to EVPN domains and CEs connected to IPVPN domains, and those CEs must be able to talk to each other. So in other words, you will end up with some gateways in your network that are able to convert from EVPN to IPVPN and vice versa. So in that situation, we need to solve some issues or some potential issues. So one of the things we try to address in the document is the BGP route selection across the different SAFIs, so across IPVPN and EVPN for the same prefixes. We also try to address loop prevention that you could end up with in this, with these gateways. And the other thing we try to address is the path attribute propagation across different SAFIs. So it is in the draft, if you start reading, you will see that we devote a pretty big section to terminology. We think it's very important to settle on the terminology that we are using in the rest of the document. And here we talk about interworking Ps, and interworking P is actually this P that has to receive and process EVPN routes and IPVPN routes in the same IP verb for the same tenant. And these interworking Ps, because they need to handle IPVPN and also EVPN, they will have like an IP verb per tenant, and they will have a set of MAC verbs attached to those IP verbs. And within each MAC verb, you may have one or multiple broadcast domains, right? That is EVPN terminology. Now you can have also MPLS or IP tunnels connected to IP verbs and the MAC verbs, and attachment circuits that can be connected to, again, either broadcast domains in EVPN or the IP verb directly. In addition to that, you will have your BGP module handling multiple SAFIs, 128, SAFI 1 as well, and EVPN. So with that, there are three very important concepts we clarify in the terminology section: the composite P, the gateway P concept, and the concept of the domain itself. Let's start with the last one, a domain. So what we refer to when we say domain is basically a set of IP verbs that provide connectivity for the same tenant. And those IP verbs can actually handle EVPN and IPVPN routes. And I give you here two examples so that you can actually get hold of this, what this domain means. By the way, each domain has a domain identifier that should be auto-derived or configured on the IP verbs. And in the typical DCI solution that you can have on the, you see here on the left-hand side of the slide, you normally have like EVPN domains in data centers, and they are connected by an IPVPN domain in the WAN, right? It's a typical deployment nowadays. So we define that two Ps are in the same domain if in the data path there are no tenant IP lookups required in any intermediate router. In this case, in the left-hand side example, when you send packets from the left-hand side P, they go to a gateway P, and then you need to do an IP lookup in order to forward the packet to the next gateway, and finally to the remote P. So because you have multiple IP lookups in between, so each one is actually happening in the same domain. So in this example, you will have 3 domains, and the gateway Ps would provide connectivity between the domains. In the right-hand side example, you have a single domain. Even though it's, again, you are connecting, for instance, to data centers through a WAN network, the data center gateways are not gateways as such, but you use, ASBRs to to make the connectivity. So between the two PEs, let's say you have a BGP labeled unicast tunnel, and you have a direct EVPN session between them. So in this case, we talk about a single domain, because there's no, in the data path, there is no IP lookup for the tenant packets between the two PEs, right? So that is the domain concept. Now, once we have a clear idea what a domain is, you can have two types of interworking PEs. So the composite PE or the gateway PE. The composite PE is basically, the intent is you have a mix of IPVPN and EVPN PEs in the same domain. So they are connected by the same tunnels, right? And you need to make sure that you provide connectivity for CEs that are connected to IPVPN PEs or these composite PEs. So what we do on the composite PEs is we advertise the same prefix multiple times, one per SAFI, per inter-subnet forwarding SAFI. By the way, we also define this concept of the inter-subnet forwarding SAFI, and that is basically a SAFI that you use to exchange prefixes for a given tenant. And the ones that we are defining are EVPN, VPN IPv4, IPv6, etc. So in a nutshell, it's EVPN, SAFI 128, and SAFI 1. The other interworking PE type is the gateway PE, and this is the we define a gateway PE as a PE that has to advertise prefixes in different inter-subnet forwarding SAFIs to different BGP neighbors. And the classical example would be a data center gateway that provides connectivity between EVPN and IPVPN for a given tenant. The other thing we defined is a new path attribute for BGP. We call it DPath, domain path attribute. And this attribute, we use it for loop prevention and also for the inter-subnet forwarding SAFI visibility. This attribute is composed by a length field and a list of domain segments, where each domain segment is composed by a domain identifier and this inter-subnet forwarding SAFI type. So the idea is that it works pretty much like an AS path, but irrespective of the AS, right? And is actually giving us the idea of how many domains a given prefix has gone through until I receive that prefix. So here in the second bullet at the end gives an example. So if I receive a prefix route with a DPath that is containing two segments, 6500:2 IPVPN and 6500:1 EVPN, I know that if I look at the rightmost segment, I know that the prefix was originated from domain 6500:1, and it was EVPN. And it also went through a second gateway that actually learned the prefix from IPVPN and domain ID 6500:2 IPVPN. So in addition to give us more visibility of the different domains that a given prefix is traversing, it's also allowing us to detect loops. So if I'm receiving this prefix with a DPath and I see on the list that one of the domains is my own local domain, I can flag the route as a looped route. The other thing we are doing is to talk about the route selection across different SAFIs. So in BGP, RFC 4271, basically you have the path selection, the best path selection, but usually for routes of the same SAFI. So here we are extending that across different SAFIs, for instance, EVPN and IPVPN. So and here basically you have a summary of what we agreed. So the idea is that you, at the beginning of this process, you have a set of best paths for EVPN and a set of best paths for IP SAFI or SAFI 128. And basically the intent is that we need to come up with a set of best paths from the union of those two groups. So what we do first is we remove from consideration the lowest local preference routes. We also remove from consideration the routes that do not have the shortest D path. And in the step number 2, basically, then we follow regular RFC 4271 selection criteria. And if at the end of that, we still have EVPN route type 2 and route type 5, we basically, we prefer route type 2 always. And step number 4 is basically if the previous steps still give us, you know, a set of ECMP paths between IP and EVPN, by default, we pick up the EVPN path. But if you configure the box for ECMP, basically we can allow ECMP across EVPN and IPVPN paths. The other thing we are doing, and this requires a bit more thought, but basically we are defining the path attribute propagation across different SAFIs. So from EVPN to IPVPN, for instance. There are 2 modes of operation. The default one is no propagation mode. So you receive an EVPN route, you install it in the IPVerf, and when you need to re-advertise it, basically you re-originate the attributes, the path attributes. And the other alternative is to have this uniform propagation mode, and then here we are defining the attributes that you should propagate between EVPN and IPVPN. And this is the initial thought. And then we define the operational procedures for both composite Ps and gateway Ps. So in the case of composite Ps, again, you have a single domain where you have IPVPN Ps and you have composite Ps. So the composite Ps will send a prefix for both IPVPN and EVPN SAFIs. And when a composite P receives both, they will actually select the best path based on the route selection that we saw before. For the gateways Ps, it's a little bit more complicated because we receive from one SAFI, we need to re-advertise to the other one. So we define the rules to make that re-advertisement happening. And we also set the rules for inserting the dpath attribute and also to detect loops. So this is basically the gateway P. And of course, there are also combinations of both interworking functions. You can have on the same network, you can have a gateway P that is at the same time a composite P, right? And there's also a section in the draft describing what to do in that case. So again, even though it's a revision 00, we've spent a lot of time discussing all these concepts, but of course, we would like to, there's a lot of work to do still. We need to give more thought to certain sections of the draft, but we would like to request feedback and more discussion from the working group.
I have a comment regarding, sorry, Neeraj Malhotra,
Excuse me.
Cisco.
Could you state your name, please?
Neeraj, Cisco. So I have a comment regarding the gateway P functionality. Perhaps, I mean, by the way, it's a very useful draft. With respect to the gateway P, it might be useful to consider a use case where the gateway P is shared across multiple EVPN domains. For example, let's say you have a shared DCI gateway that is doing the DCI gateway function for 2 data centers. So it's basically connected to 2 local data center domains via EVPN, and it's doing IPVPN or EVPN-based DCI function for that. I mean, in terms of being able to control with respect to which domain needs to be stitched to which domain, rather than having a default stitching between EVPN to IPVPN.
Okay, so the draft supports that use case. We haven't included it explicitly. It's something that if it is needed, we can add we can add it to the use
Sure.
cases.
Yeah, I can discuss offline. I can give you some more.
Sounds good. Thank you.
Thanks.
All right. Thank you. So the next one is just an update. It's pretty quick. So this is the proxy, PIM proxy and EVPN networks draft. This is revision 01. So we presented this in the last IETF. You have here the list of my co-authors. And just a short refresher. So the idea is this is natural extension of the current EVPN work. So in an EVPN broadcast domain, as you know, so one of the goals is to reduce the amount of bump traffic, especially as C-based control plane protocols that are generating bump traffic. So along the same lines as we do with ARP or enable discovery, we have mechanisms to actually reduce and suppress that traffic. We do the same thing for IGMP proxy. There's a separate draft for that. And this is yet another work to actually do the same thing with PIM proxy. So when you use an EVPN broadcast domain to connect PIM routers, what we want is actually just to stop flooding all those PIM messages, right? That's one thing. And the other thing we want to do is to convert those soft state PIM messages into hard state BGP routes. That is also helping. And we are also introducing some improvements to avoid IP multicast duplication and improve the assert procedures on the CEs, right? And finally, we are also supporting because you may have a EVPN multi-home with single active and all active. We want to also leverage the work that we have in the IGMP proxy draft to do pretty much the same thing, synchronize multicast states across all the PEs in the same Ethernet segment and provide a fast failover. So what we've, this is just an animation showing that basically when we receive hellos, we are able to turn those into BGP routes and generate hellos as the egress PEs. And we do the same thing for PIM join and PIM prune messages. So updates in revision 01. Based on the feedback that we got, we removed the sections that we had and we started to work on about PIM dense, bootstrap, and RP discovery. The feedback was that it was really not necessary. We also got the agreement to reuse the existing EVPN routes. So in the IGMP proxy draft, we are using the SMIT route, and we are using the IGMP join sync route. Those routes can be easily extended a little bit for this draft, and then we can reuse the same route type and the same structure and similar procedures. And we also added a caveat that one of the authors pointed out, and that is when you have when you don't have the upstream PIM routers connected directly to broadcast domain attachment circuits, you may end up in a situation where you have a source and an upstream router that you are not selecting for the assert procedures, and you may have some issues there. So it's kind of a corner case scenario, but it was good to document. And so that's pretty much it. We believe at this point in time, since this is a natural evolution of the also the IGMP proxy draft, we believe it's ready for working group adoption.
Mankamna Misra from Cisco. So I had one question about your route type 6 and 7, which you are reusing in this PIM proxy draft.
Mm-hmm.
So do we really need two separate draft updating the same route type at same time? Because even IGMP proxy, it's still a draft, it's not RFC. So I was just trying to understand, why do we need to overload here again? I mean to say, can't we have single document which does, because IGMP proxy and PIM proxy kind of they're talking in same segment of solution.
Yeah, for the Smith route, that's exactly the reason why we are using the same route. We only need to extend it with the upstream neighbor IP address, right?
Yeah, so my question was why to have two drafts for same route types?
Yeah. So for if you only use IGMP, you don't need the upstream neighbor IP in the NLRI, right? So why would you use it? So, but essentially it's the same route, it's similar procedures, but you may have two completely separate applications, or you can have both in the same network.
Okay, maybe I'll talk.
Okay.
Are you suggesting to merge the drafts? But there are two different applications, apple and oranges. One is IGMP, the other one PIM. Doesn't matter. I mean, you can, leverage.
Yeah,
the
I agree with.
intention was to leverage the route types as opposed to reinvent and reintroduce new route types. But the applications, as you can see, are quite different.
I agree with Ali. It's this is defining different procedures as well. So some of them are common, but yeah, different applications, indeed. Any more questions? Okay, thank you very much.
Thank you, Jorge. Yash?
Morning, folks. Neeraj Malhotra, Cisco. So I'm going to be talking about unequal load balancing procedure for EVPN and the requirement for it. So the main sort of context for this is multipath procedures that are currently defined in RFC 7432 for unicast traffic, and that enable ECMP-based load balancing across a set of multi-homing PEs, and the DF election procedures that are defined in 7432 that intend to achieve sort of equal service carving across a set of multi-homing PEs. So with respect to the unicast traffic, if you consider an ESI that is multi-homed to two PEs, the unicast multipath procedures essentially enable equal load balancing of all the traffic. If you consider like all the flows that are destined to that ESI across all the EVPN instances, the multipath procedures try to achieve sort of equal distribution of traffic or flows across the set of two PEs. So you would expect essentially half the flows across all EVPN instances destined to ESI 1 to go to PE1 and the other half to go to PE2. And however, the problem with this is essentially that if you have an asymmetric distribution of bandwidth within the ESI across the set of multi-homing PEs, the existing multipath procedures would still result in equal load balancing of flows across the two PEs. So essentially, you would expect half the flows to still go to PE1 and half the flows to still go to PE2. So this is kind of suboptimal, and that suboptimal behavior is what is sort of one of the main problem statements for this draft. Similarly, with respect to bump traffic, the distribution of bump traffic forwarding on the ESI is determined by the service carving or per service DF role assignment across different services enabled on that ESI across the set of multi-homing PEs. And as a result of the existing DF election procedures, you would expect, again, sort of like a half split of DF role across all the services that are enabled, or all the VLANs, so to speak, that are enabled on that ESI across a set of multi-homing PEs. Again, the suboptimal behavior here occurs with respect to bump traffic as well. If you have an asymmetric split of bandwidth within the ESI across the multi-homing PEs, for example, you have double the bandwidth on PE1 side and half the bandwidth on PE2 side, the bump traffic DF role, DF designated forwarding role would still be equally split across the two PEs. So essentially, the objective of the draft is to have the overlay unicast flows load balanced across a set of multi-homing PEs in proportion to the link bandwidth, or rather the relative link bandwidth that that particular PE has within the ESI. As well as with respect to the bump traffic, have the DF role across the, or the service carving across a set of multi-homing PEs also distributed in proportion to the relative bandwidth that that PE has within that ESI. So essentially, now when you have an asymmetric distribution of bandwidth across a set of multi-homing PEs, the desired behavior is that in this particular example, let's say PE1 has 200 gigs of bandwidth and PE2 has 100 gigs of bandwidth on that ESI that is shared across PE1 and PE2. The desired behavior would be to have 2/3 of the flows destined to ESI1 be forwarded to PE1 and 1/3 of flows destined to that ESI being forwarded via PE2. Similarly, with respect to bump traffic, to sort of achieve optimal forwarding, you would want, in the same example, PE1 to be the designated forwarder for 2/3 of the EVPN instances and PE2 to be the designated forwarder for 1/3 of all the EVPN instances that are enabled on that ESI. So the solution that is proposed here, it's fairly straightforward. Basically, what we're proposing is for the local PE to advertise a link bandwidth attribute together with the per ES Ethernet auto discovery route. So this is basically an ESI, an attribute you could think of as a property of the ESI being advertised from that local PE. The attribute definition itself, we're trying to reuse an existing BGP extended community that is defined in an earlier draft for layer 3 VPNs because it pretty much enables a similar kind of function for EVPN. On the remote PE side, again, pretty intuitive functionality. You collect the link bandwidth attributes for a given ESI received from all the PEs within the redundancy group for that ESI. And then you essentially program your load balancing, forwarding load balancing in a weighted fashion. You compute relative weights for each PE for that ESI, and you compute your forwarding path list or load balancing structure based on those weights. With respect to bump traffic, the DF service carving, we're still discussing it. So that's not yet covered in the version 0 of the draft. There is some overlap with the existing preference-based DF election algorithm, and there are other DF election algorithms that are defined. So we're basically, discussing with other co-authors for revision 1 as to exactly how to address it. So next steps, basically couple of key work areas. One is the DF election part that I just discussed, that is being discussed with the other co-authors for the next revision. The BGP link bandwidth extended community, that draft has expired. So we are discussing as to how to reinstate the attribute definition and reuse it. So that's basically it. Basically looking for more reviews and more comments.
Jorge Rabadan, Nokia. So thanks for this document, Niraj. I think it's very useful. About the BAM traffic, I think we pretty much got to an agreement yesterday. So hopefully we can reflect that in the next revision. I had a comment about the link bandwidth extended community. At the moment, it's defined as a non-transitive extended community. Have you thought about inter-yes? And if we need to fix that, I guess we do.
I have not, frankly. So yeah, let's discuss. Let's see
we should fix that.
How to handle that. Sure.
Right.
One quick comment, continuation of what Jorge was saying. Given the DF election, our DF election allows for going across AS, then this needs to be transitive as well.
I see.
So, Jephton, sorry, same comment about being non-transitive, and in general, it would be very good to actually finish the standardization. There are at least 6 or 7 implementations. So, please do so.
Yeah, certainly. Yeah.
Jeffrey Zhang. For Unicast load balancing, I'm curious how effective it's going to be, because I assuming that the ingress PEs will try to send traffic according to the link bandwidth, but different PEs could be sending traffic differently. One PE could be sending a lot, another PE will be sending.
Yeah, I mean that's an inherent problem with per flow load balancing, right? I mean, it doesn't guarantee. It intends to spread the traffic. Even, I mean, that's a problem with ECMP as well, that you never actually, in terms of the actual packet rate, get equal distribution, because you can have elephant flows and smaller flows. So the load balancing granularity is per flow, but within that limitation, I mean, what this is trying to achieve is essentially, do sort of that flow level granularity load balancing in proportion to the link bandwidth, rather than have it equal.
I'm not challenging, just curious. That's all.
Yeah, sure. Thanks.
Oh, I'm not challenging that. I just curious how you.
Yeah. No, that's a valid point. I mean, that's kind of inherent issue with flow level load balancing.
Stefan from Orange. I just want to give my opinion also that link bandwidth is clearly the good solution to go, and we need to reactivate the draft, make it transitive if you need.
Sure. Thanks.
So while looking into data center stuff, we kind of looked at flowlet signaling. It seems to be extremely complicated, since you need to make sure packets don't get reordered. You need to count intergap delays.
Yeah.
So it's definitely of interest to look, especially in a VPN case where elephant flows could be 20 elephants wide, right?
Right. Yeah.
So I think working group we should look into this.
Sure. I mean, it's a hard problem to solve. There is thought process in that direction. I mean, to do some kind of adaptive load balancing based on link utilization, but nothing concrete.
Hi, Himanshu from Siena. Similar comments. If you have multiple remote PEs, right, they're sending it to this PE1 and PE2. How do you coordinate, from the remote ingress PEs with respect to how the traffic is distributed, right? They are all taking independent, and obviously with elephant and mouse flows and all that stuff on a given single PE. But if you have multiple remote PEs, then you have a gain.
I mean, the elephant and mouse flow problem aside, I don't see a problem with multiple remote PEs forwarding. I mean, basically each remote PE, instead of whatever flows it is generating from the local hosts, instead of load balancing them equally across the 2 remote PEs, it is going to basically distribute its local flows in a proportional manner. So overall, across all the PEs, you would expect all the flows from all the remote PEs to be distributed in like 2/3 to 1/3 manner, for example, instead of ECMP.
So I hear what you're saying, but I don't necessarily agree with you. Okay.
Okay.
Because it's an individual decision being made at the remote ingress PEs, right?
Sure.
And they are, but depending on who's sending and who's not, and
Basically, what we're trying to do, we're trying to make sure that the remote PE they have visibility, have the visibility into these ES so that they can do proper load balancing. So if implementation is messed up, then that's beyond our control.
No, I think you need some kind of a feedback loop as to which ones are congested.
So
maybe your 200G is very much congested, and 100G.
We are not trying to boil the ocean in here. We are trying to say, okay, currently, if you look at the load balancing that is performed by the remote PE is blindly done between the PE1 and the PE2 equally. We are saying that now do it on a weighted basis, and the weight is the link bandwidth. So we are doing an additional improvement. We are not trying to, solve the world hunger problem here. One additional comment I'd like to add is in the next rev, can be. No, mine is related to this. In the next rev, can we please put a clarification that the non-even flow, e.g. elephant and mouse flow is outside the scope of this?
Sure. Yeah, it makes sense.
Yeah, Stefan from Edge, to come back also to this. Yes, this is a distributed routing issue, so you cannot control globally your network. So yes, this is a good way to go. And if you want a kind of global optimization, you may need, kind of central controller to re-optimize your flow. And there is no other way to do.
Right. Thanks. Okay, so I mean, this is going to be pretty short. So I just have like some very quick updates on the IRB mobility draft. So the version 0 of this draft was presented at the last IETF in Prague. Just a couple of quick updates on what is new or what has changed in the next revision. Just to recap, the draft itself is intended to extend the existing MAC mobility procedures defined in 7432 to IRB use cases, including all use cases that might result in changing MAC to IP bindings or IP to MAC bindings across mobility. The solution that was proposed in the draft, it's essentially the same. So nothing has changed with respect to the main content of the draft and the solution. It's very much aligned with the MAC mobility procedure defined in RFC 7432. It pretty much takes that and extends the sequence number assignment rules to account for scenarios where MAC IP bindings could change across mobility. So key updates to the next revision based on comments and contributions received from additional co-authors. One area is that we also included IP mobility for a routed EVPN overlay use case, where basically you have a purely routed EVPN network, and IP mobility procedures are captured in Section 8 of the document, which are pretty much aligned with MAC mobility, and they take the same procedure and apply it to IP mobility. Duplicate host detection section has been extensively rewritten. There was a lot of comments with respect to it not being very clear with respect to each use case, how it is handled. So now it goes by case basis. For each scenario, it describes the handling in greater detail, as well as it includes the IP mobility scenarios as well. Particularly the duplicate host recovery section now goes into much greater detail with each scenario and describes as to how the host or how the recovery from the duplicate or frozen MAC or IP would happen for each different scenario. Other than that, there was an overlap between duplicate IP handling with the proxy ARP draft. So we have kind of aligned it with that draft. I mean, the main sort of procedure was very much aligned with the draft, but since it is already defined in that draft, so we kind of added appropriate references and just talk about the deltas in this draft. That's basically it. So we're basically looking for more reviews and more comments on this draft from the working group to take it further. That's it. Thank you.
Thank you, Niraj.
Yeah.
We have a bit of time. Anyone wants to say something? No? Exploit the time. Okay. Thank you very much. If you haven't signed the blue sheets, there must be somewhere in the room. Please do sign them. And thank you very much for being here on Friday. I see a lot of people, as many as usual. So I'm really pleased to see that. Doesn't mean we'll continue being on Wednesday on purpose, but I'm happy for that. Anyway, thank you and see you next meeting. I don't know where. London? Finally. Hey. He's not responding. Hey. I'll try to catch him if I see him, if he still is on site. Have you tried yourself? No? Yeah. Yeah. Oh, yeah. Okay. Okay. No, I'll try to catch him anyway. Thank you. You too. Salut Samy. Ça va? Hey, man, how are you? So I'm sitting in your you mean you don't know what's happening to it? No, I mean, it is in IESG for 81 days. You go on the web page of BESS.